So this is the final review and the topics that's going to be on the final. Okay, final. So the first topic that we're going to be interested in is going to be problem number 1 that we have. And the topic is what? Is absolutely. Okay, absolutely or conditionally convergence. You know that this series would be given to and we ask you which one is the situation that we're going to have. So for example, I do the part 1, that's a 1A, and in 1A, the series is sigma of -1 to the n minus 1, and that's 1 over n radical n from 1 to infinity. It's alternating series. So since they ask for the absolutely convergence, so first you put the absolute value around it. Okay, so the solution is going to be, you consider the absolute value of a -1 to the n minus 1, 1 over n radical n from 1 to infinity. So the absolute value would take care of the -1, so that give me 1 over n radical n. And you can rewrite it as, n as n to the half. So the n times n to the first power would be 1 over n to the 3/2. And you know that this is a P series. P equal to the 3/2, and it's a convergent. So you explain that is a convergent P series. Okay, P series, you explain that because P is 3/2 and is bigger than 1, so that's why it's convergent. So you are lucky because you already got the absolute value of the term of the series is convergent. So the conclusion is going to be the series. Okay, so the series, the general series is absolutely, okay, it's going to be absolutely convergence or convergent. And then you're there. Okay, that's the case part when we put the absolute value around it, and this happened to be convergent. The case 2 is going to be, see that's 1A. So for the case 2, for the examples that you have, we go with the number, just checking which one is going to be appropriate for this one. We go for the 1E is the one. Okay, 1B is also convergent. I want to take something like, it is not going to be absolutely convergent. The second one is, you won't have any of these here. I'll give you another one myself. Okay, so this is a new one. It's like the one that you have on your worksheet, something like cosine of the n pi. Okay, cosine of the n pi, let's say over n plus 1. This is going to be the 1, and n going from 2 to infinity. The cosine of the n pi, you know that anytime you see the cosine of the n pi, because the cosine n is an integer, so cosine of the pi is a -1, cosine of the 2 pi is a +1. So anytime you have a cosine of the n pi, you write it down as a cosine of the n pi is -1 to the n. Okay, so quickly replace it by -1 to the n. So the result is going to be cosine of the -1 to the n and divided by n plus 1, n plus 2 to infinity, n from 2 to infinity, or 1 to infinity, doesn't matter. 1 or 2, all of them would be the same thing. Okay, so as soon as you see cosine of the n pi, just replace it by the -1 to the n. Now again, put the absolute value around it. So it's going to be absolute value of -1 to the n over n plus 1, okay, and from 1 to infinity. Absolute value would take care of the -1 to the n. So you end up with sigma of 1 over n plus 1. You know that this is harmonic series because it's like sigma of 1 over n. So it's going to be a p series or a harmonic series with p equal to 1, and it is divergent. So it's a divergent p series, but you explain that the p is with p equal to 1. Okay, it's a divergent p series. When it's a divergent, you see the absolute value is divergent. So this series can be conditionally convergent. Conditionally convergent means you go back and you consider the full series again. Okay, consider the full series. Say, oh, bet, what is the original series? Sigma of -1 to the n over n plus 1. You know that this is what is an alternating, okay, alternating series with the, remember the bn. If you drop -1 to the n, that will be bn, which is 1 over n plus 1. And you know that this bn must be decreasing and the limit must be 0. It's clear that the limit is 0. So the limit of bn, you have to explain it. N goes to infinity is equal to the 0. And since if you increase the n down the denominator, the fraction getting smaller and smaller. So this sequence is decreasing. So the limit of bn goes to infinity is 0, and the sequence of bn is decreasing. You have to explain the reason to get the full point. So therefore, this alternating series is convergent. Okay, so therefore it converges. So what we did, the absolute value of the series, you see the absolute value of a series is divergent, but the series by itself is convergent. And in this case, you know that the series is going to be called conditionally convergent. So the given series, I start with that cosine of the n pi over n plus 1 is going to be conditionally, okay, conditionally, it is going to be conditionally, okay, conditionally convergent. And you're done. Okay, this is the first topic that we're going to be interested in. Okay, very easy, and to go for it. So to take absolute value around that. This happened to be a nice series. Most of the time it's going to be p series. So the p series is convergent. So the series is absolutely convergent, and you're done. If you take the absolute value around it and it's happened to be divergent, so get back to the series, check the alternating series. The condition for the alternating series, if it is satisfied, the conclusion is that the series is conditionally convergent. Okay, this is topic number 1. So you have the one on that worksheet, just do it, just get practice. You did one in your quiz number 4. Okay, check that one too and be ready for it. What is topic number 2? Topic number 2, we may give you 2 questions on this one, as in your previous test, and test number 3, I think. A power series would be given to you, and we ask you to find the radius and interval of convergent. So it's going to be, the question is radius. Most of you did this one all right on the test number 3, I think. Find the radius and interval of convergence of the power series. Takes times a little bit, okay, but you should be fine. To find it, there are 2 cases. The case that the power series is going to be just powers of X, and the case stat is going to be powers of anything else. Okay, you have quite a lot in this and number 2, so I just quickly check 2 of these for you. Okay, check number 1. Most of them are the same. Part 1. In number 2, this is when you have the series in terms of the powers of X minus 5. So this is a negative 1 to the n. Again, the X minus 5, everything to the n over n 5 to the n. Okay, n equal to the 1 to infinity. You know that for these power series, you have to use the ratio test, limit of an plus 1 over an. And we know that the result of the ratio test, if it's going to be less than 1, the series is convergent. Otherwise, it's divergent. So you are going to take that one and you force the result to be less than 1 to find the radius of convergent, and then you check the number of the x on the endpoint of the interval to find out the interval of convergence. Okay, so it's clear what to do. So start with that test, limit the absolute value of an plus 1 over an. Remember, it's an plus 1. Some of you on the test, you switch it, which is not correct. Okay, so in short, you see when you divide, it's going to be x minus 5 to the n plus 1, divided by x minus 5 to the n. So x to the 5n would cancel out, so the leftover is going to be absolute value of x minus 5. You can make it short for yourself. And then it's going to be the limit of n goes to infinity. That absolute value would take care of negative 1 to the n. So for the leftover, the top is going to be 1 over n plus 1 times 5 to the n plus 1 on the top. You see it's a 1 over n plus 1 times 5 to the n plus 1 on the top, and divided by an, which is going to be 1 over n to the 5 to the n. Okay, easy to write. You write the first one multiplied by the reciprocal of the other one to simplify it. So x minus 5, the limit of n goes to infinity. So that would be 1 over n plus 1 times 5 to the n plus 1. Use the reciprocal n, 5 to the n over, over 1. Now simplify it carefully, 5 to the n. This would cancel out, the leftover is going to be 5. And so the result is going to be the absolute value of x minus 5, and the limit of n goes to infinity. On the top, you are going to get the n. Down the bottom, we get a 5 times n plus 1. When n goes to infinity, you know that the leading term, this limit would be a fifth, because the 5n now. So it's going to be absolute value of x minus 5. I explained it for you. Limit of n on the top, 5 times n down the bottom, the leading term. So it make it to the 1/5. So absolute value of x minus 5 times the 1/5, which is the same as the 1/5, the absolute value of x minus 5. So that would be the result. Now you force it to be less than 1, because if it's going to be less than 1, you know that the series is convergent. Now you solve for the absolute value part. You solve for the absolute value, mean you multiply by 5. So x minus 5 would be less than 5. As soon as you get the absolute value less than 5 or less than whatever, this will tell you that the radius of convergence is 5. Okay, so R is equal to the 5, and the series converges. The series converges. You open up that absolute value converges. Okay, when so absolute value less than 5 would be x minus 5, less than 5, and greater than negative 5. So for x, so that gives negative 5 plus 5, less than x, and that's going to be 5 plus 5. So that gives x less than 10 and greater than 0. So far, this is going to be the domain of the convergence or interval of the convergence. But you have to check the series at the endpoints. You're not done. Okay, so check for x equal to the 0 and x equal to the 10. So you may get more points. Otherwise, this would be the interval of the convergence. Okay, x equal to the 0 in the original series, and carefully. This is the original series. So we substitute x equal to the 0. So that gives us a sigma of -1 to the n. Okay, x equal to the 0, that gives 0 minus 5 to the n. And this is going to be n 5 to the n. So it's equal to the sigma of -1 to the n. So -5 to the n would be, that would be -5 to the n, or n5 to the n. You pull out the -1, so it's equal to the sigma of -1 to the n. You see the top would be -1 to the n, carefully, and that's a 5 to the n, and over the n, 5 to the n. So 5 to the n and 5 to the n would cancel out. -1 to the n and -1 to the n, you add the powers. So that gives a sigma of -1 to the 2n. And the leftover is going to be 1 over n. -1 to the 2n is an even number. So that gives a positive 1. So that gives sigma of 1 over n. And you know that this is harmonic series, it's divergent. So we can say that is a divergent p-series, with p equal to 1. So the power series is not convergent at x equal to the 0. Okay, so make a note for yourself that the power series, diverges when x equal to the 0. So we didn't get anything for x equal to the 0. Okay, but we have to check for x equal to 10. So we're going to do the same thing. We put x equal to 10, then 10 minus 5, that gives you 5 to the n. So in that case, 5 to the n would cancel out, and you get -1 to the n over n, which is convergent alternating series. Okay, so I'm going to do it. This is, you have to check both of them, remember. So we're checking x equal to 10 in the original series. So that gives us a sigma of -1 to the n. Okay, -1 to the n, 10 minus 5 to the n. Okay, that would be n 5 to the n. So it's a sigma of -1 to the n. The top would be 5 to the n, and 5 to the n. Okay, now 5 to the n and 5 to the n would cancel out. So that gives you sigma of -1 to the n, 1 over n. Okay, and you know that this is what this is convergent, alternating convergent series is a convergent, you know, it's harmonic series, we know it. It's a convergent alternating series. You don't have to check anything because that's the famous convergent alternating series. So the power series, okay, so the power series is convergent, is going to be convergent when x equal to 10. So the conclusion is going to be, this is it. So the conclusion is that the radius of convergent was 5, and the interval of convergent start from 0 and 10, but it's not convergent at 0, but it's convergence at 10. So that gives you the radius of convergence of the power series. Okay, just, you can read the rest yourself. It may be x to the n, which is much easier, like the part B. So you can try part B for yourself. Just make sure you know both of them. Okay, the part B is easier. You see, it's easier. It's a -1 to the n, x to the n over n squared. When n goes from 1 to infinity. In this case, it's going to round the x, so the radius of convergence is much easier. For this one, the radius convergence would be 1. And the series, then, just check the one that we have on the, the solution. So this would be the idea of, so you have the 1b, you check it from the, so in this case, r is equal to 1. Check the solution set that I gave you, and the series is convergent in this interval. Okay, so we may give you 2 questions, one of these 2 types, okay, for the power series as you did it before. So that's a topic number 2. We have a series of this in number 2, and you have all the solutions on the final review. So check them, make sure you are ready for it, be quick. Okay, so this is topic number 2. So we make it 3 questions so far. This topic is writing the power series for the functions. This would involve a kind of 2 different types of functions. Okay, the first group are going to be easy because we are going to use a shortcut. Okay, so the next topic is power series. Okay, power series representation. Power series representation of functions. The key for this question is this one. You see 1 over 1 minus x. Remember, this is the geometric series. It's going to be equal to the 1 plus x squared up to the, plus x to the n. Because to the right is the geometric series, and this geometric series with the common ratio of x, and the first term is a. So you know that s is equal to the a over 1 minus r, and the r is x. So this is convergent if the absolute value of x is less than 1. The key for this question is this one. You may have to modify it if you have anything else to do. You may have a 2x. So you write this one, you multiply it, replace it by 2x. But the radius of convergence is important. Okay, so whatever you pick for the x, you may have to change this one. So it is in expanded form or in sigma form. It's a sigma of x to the n from 0 to infinity is equal to the 1 over 1 minus x, but with one condition. The condition is the absolute value of x is less than 1. If you don't write this condition, you are not going to get match points, because the eats happen only if the absolute value of x is less than 1. Okay, so you can refer to this one. You have to mention it if you want to use it. Okay, and then this is the key for all these questions on this part that we're going to give for the first power series, because otherwise you have to use the Taylor series, etc. But that's a shortcut that we can use. Okay, so they may change it. So for example, at the first part, they ask you for the power series for this function, f of x equal to the 1 over 1 minus 3x. You see you have the x, this is 3x. So you write this one and you replace the x by 3x, done. Okay, this is how we're going to answer it. The solution is going to be, say that, note that. You can write it down in expanded form or just general form. The general form would be fine for this type of problems. So you note that, that's it. You note that the 1 over 1 minus x is sigma of x to the n from 0 to infinity, with the condition that the absolute value of x is less than 1. Now you replace the x by 3x. So now you let x to be equal to the 3x. You substitute that, give 1 over 1 minus 3x equal to the sigma of 3x to the n, okay, n from 0 to infinity, absolute value of 3x less than 1. But this is not a power series. The power series is in terms of powers of x. So you have to raise this one, simplify it. So it's going to be equal to the sigma of 3 to the x to the n, and the absolute value must be absolute value of x, not the 3x. So you pull out the 3 absolute value of x is less than 1. Now, and then you continue the absolute value of x less than 1/3. If you write it down right away, I accept it. So the conclusion is going to be, you see, 1 over 1 minus 3x is sigma of 3 to the n, x to the n from 0 to infinity, when the absolute value of x is less than 1/3, and then you're done. Okay, so this is the power series because of the x to the n, and the radius of convergence is 1/3. You know, you can write down an expanded form. You don't have to, you know, replace x by 0 and get these numbers. You don't need this one, and then you're done. So the final answer is this one. The limits of the sigma must be nicely given, and from 0 to infinity, and then you're done. Okay, so that's first part. So the key is this one. So if you have a 1 plus 3x, so part B, you've been asked to write the power series for this one. G of x equal to 1 over 1 plus 3x. Okay, that's the one. Again, it's 1 plus. Again, you start to explain. Note that you have to write this one, repeat it. 1 over 1 minus x, again, is sigma of x to the n from 0 to infinity, with the condition that the absolute value of x is less than 1. So what I'm going to do, you need the 3x here. So you replace the x by negative 3x. So you're going to let x to be equal to negative 3x. So that gives 1 over 1. You see, there is a negative. Negative would be positive. 1 plus 3x. And this is going to be sigma of negative 3x to the n from 0 to infinity, and the absolute value of negative 3x less than 1. Again, you have to simplify it. You see negative 3 to the n, is the way you write it down. It's a negative 1 to the n, sigma of negative 1 to the n, 3 to the n, x to the n, 1 by 1, n from 0 to infinity. Absolute value of negative 3 would be 3. So this is going to be again like the one that I did for the other one. You pull out the 3 and you divide by 3. So the absolute value of x less than 1/3. And then you're done. Okay, it's very easy procedure. That's the advantage of that geometric series that we have. Again, I repeat, if you don't write the radius of convergent, your series is not valid and you lose points. Because without this condition, it doesn't make sense. You know that the series is convergent in a specific interval. You have to give us that radius of, we don't need the interval of convergence. Okay, so it's going to be case 2. The case 3 is if you get a power. Okay, if you get a power over here, then for the power, you have to use the derivative of these functions, okay? So I give you the part C. The part C, the function is f of x. The part C, you need a little bit more algebra to do. 1 over 4 plus 3x all squared. You see the power of, if it's going to be a squared, you write the power series for 1 over 4 plus 3x first, then you differentiate it. If you differentiate it once, that gives you a squared. If it's going to be to the third, you have to differentiate it twice. At first, you have to make that 1 over 4 plus 3x, which is interesting by itself. Okay, so again, what we are going to do, we are going to use that idea that we did. Again, you say that the note that you are going to make this one. This is the way we're going to do it. This is 1 over 4 plus 3x. To use that theorem, this must be 1. It's 4. Factor it out. It's going to be 1 over 4 out 1 plus 3x over 4. Let's see. 3x over 4 would be a quarter. And this is going to be 1 over 1 plus 3x over 4. Now you go to that power series, geometric series, and replace the x by negative 3x, okay? So replace the x by negative 3x over 4. So this is going to be equal to a quarter outside. We get the sigma of x to the n. X would be negative 3x over 4 to the n. But with the condition that the absolute value of negative 3x over 4 less than 1. Again, if you don't write the conditions, it's not correct. But we have to pull out the x here. So it's going to be a quarter sigma of, that negative signs becomes a negative 1 to the n, 3 to the n, 4 to the n, x to the n. Now the absolute value, you pull out the 3/4 and then you divide by 3/4. So it's going to be absolute value of x less than 4/3. Okay, because this is going to be 3/4 of the absolute value of x. You divide both sides by 3/4, that gives you 4/3. That's it. So what we did is 1 over 4 plus 3x is equal to a quarter sigma of negative 1 to the n, 3 to the n, 4 to the n, x to the n, with the condition that the absolute value of x is less than 4/3. You see, you have to provide this series vector. By itself, it's interesting how we're going to make, 1 over 4 plus 3x. Now, since it's a square, differentiate both sides. Okay, differentiate by respect to the x. So, differentiate. Okay, differentiate with respect to x. Derivative of this one, you can use quotient rule if you like. Derivative of the top times bottom would be 0. Minus derivative of the bottom times top. Okay, this is it. Derivative of the top times bottom would be 0. Minus derivative of the bottom. Derivative of 4 is 0. That gives you negative 3. Times top. Divided by the bottom is square. 4 plus 3x all squared. Okay, I used the quotient rule. Derivative of the top is 0. Minus derivative of the bottom is 3 times top, which is 1. Divided by the bottom is squared. You do the same thing here, but you do only to the x. It's going to be a quarter sigma of negative 1 to the n. Okay, 3 to the n, 4 to the n, and this would be n x to the n minus 1. The only part that you differentiate. Okay, and since it's going to be n minus 1, your sigma starts from n. Because you cannot have a negative power. If you put n equal to 0, x would be negative 1. Simplify if you get anything. That's going to be matched really. There's going to be negative 3 here. So it's going to be negative 3. Okay, that's a 4 plus 3x all squared. And you can take a quarter inside or just outside, doesn't matter. It's going to be f4. Okay, it's a negative 1 to the n, 3 to the n, 4 to the n, and that's going to be n x to the n minus 1. I missed the sigma. You can divide both sides by negative 3 to get the one you are interested in. It's going to be 1 over 4 plus 3x all squared. And if you divide by negative 3 both sides, so that give me negative, a quarter here, 3, 12. And that's going to be sigma of negative 1 to the n, 3 to the n, 4 to the n, n x to the n minus 1. But remember the absolute value of convergent, I missed this, absolute value less than 4/3. Or make sure that the last time that you write it, it is there. Okay. So that would be interesting part that you have to, okay, you have to differentiate it. On the solution set, part C, I just give you 1 over 4 plus 3x. I didn't differentiate it, okay? Just make sure you correct this one. You see that's the solution that you have. Solution that you have is this one, or part C. You pull out the 4, I formed the series, okay? Then I forgot to square it, because the original one was not a square, then I put the square around it, okay? So double check it. Make sure you don't miss it. And these solutions are correct. Okay, so it's not done. This is good if the function is 1 over 4 plus 3x. But since it's 1 over 4 plus 3x squared, I squared it later. Then you have to differentiate. You differentiate it, they raise it, they raise the power. Okay, quite interesting. Otherwise, if you want to use Taylor series to write this, oh, good luck. It would be difficult. It can be done, but it would be difficult. Okay, make sure that the n from 1 to infinity. Some people, they pull out the 12 here, just add it to the power of the 3 and the 4. You don't have to really, just make it simple. And make sure that you give us the radius of convergence. Okay, so this is it by itself, easy into important questions as is on this review. But if you get a power, just square it. Okay, I give you another one so that make sure you understand this one. You see the part D that you have, and the part D, the power is 3. Again, on the review is 2. That's why I check this one for you too. So it's going to be 3. Let me give you something that you differentiated twice for us. Okay, so correct this one on your review solutions, because I changed it a little bit, make it more interesting for you. So the part D is the function is h of x. If you want to continue taking courses in, especially in differential equation, this idea would be useful for you. And if you're measuring physics or engineering, use this type of idea quite a lot. This is the way your calculator would operate. Anything you want, because the calculator uses the power series. Okay, check this one. As soon as you see the power, forget about the power. You see, do 1 over 1 plus x first. And for each power, you have to differentiate. If you differentiate it once, that gives 1 plus 1 over x squared. If you need the third, you have to differentiate it twice. Okay, so we go for it, and that's it. First, we start with the 1 over 1 plus x. Again, and note that you can do it quickly. It's a 1 over 1 plus x. We go to the power series and replace the x by negative x. So that gives a sigma of negative x to the n from 0 to infinity. We accept this if you do it right away. You have to take care of the negative sign. It's a negative 1 to the n, x to the n from 0 to infinity, but don't forget the condition. The condition is the absolute value of x is less than 1. Okay, you have to provide the original one first, 1 over 1 plus x. Okay, now what we are going to do, you need the powers differentiate. So differentiate. We are going to differentiate it again with respect to x. If you use quotient rule for this one, the derivative of the top times bottom would be 0. If top bottom is a -1 times top, so that gives you -1 divided by 1 plus x all squared. That's the derivative of this part. Go to the other part, we just differentiate in x to the n. So that gives a sigma of -1 to the n, and it's going to be nx to the n minus 1 again. But make sure that you start n from 1 to infinity because of this power, and the radius of convergence is 1. Okay, but you need the third power. So what you can do is you can differentiate it again, derivative of -1 over 1 plus x squared. Again, you can use the quotient rule. Derivative of the top times bottom would be 0, bottom top. Okay, differentiate again. Because the power is 3. Again, on your review, you have the power. Okay, you have it. You know, this is the -1 minus x squared only. So I just changed this one a little bit. Just be careful. Just check it. Okay, and you have it again. So you see, you have two versions of these solutions, and this is it. So we have it here too. Okay, it's two different pages, but you have the solution. So we differentiate again. Derivative of the top times bottom would be 0. Derivative of the bottom times top would be 2 times 1 plus x. And this would be 1 plus x all the square, which is to the 4th. And we differentiate the other side. It's a -1 to the n. It's going to be n times n minus 1, but x to the n minus 2. Now n must start from 2 here, 2 to infinity. But the radius of convergence would be unchanged. Okay, you simplify these two. So that gives you the third power that you are going to be interested in. So it's going to be 2 over 1 plus x to the, okay, 1 plus x to the third. Okay, 1 plus x to the third. And this is going to be what? It's going to be equal to sigma of -1 to the n. Okay, -1 to the n, you have the n times n minus 1, x to the n minus 2, n from 2 to infinity. Absolute value of x is less than 1. Just divide by 2. That gives 1 over 1 plus x cubed. That gives 1/2 sigma of -1 to the n, n times n minus 1, x to the n minus 2, with the condition that absolute value of x is less than 1, and you're done. Okay, very, very popular method, and you must know it. So make sure that you check it. On the solution set that you have, there is a misprint over here because I differentiated once, that give me n x to the n minus 1. When I differentiate it again, so this must be n minus 2. Because it's going to be n times. This is going to be n minus 2, and this would be n minus 2. Okay, so the final answer, 1/2 of a sigma -1 to the n times n minus 1, x to the n minus 2, x to the n minus 2, okay, with the radius of convergence of less than 1. So very important properties of the power series, and we give you one. Okay, we may give 1 or 2. One that's going to be ordinary function, and you have it on that worksheet that I gave you. You have something that you have a square. So when it's a square, it's just the first derivative, but we check it. So we check it with the at least first derivative to make sure you know it. Okay, so there are some special one that you have it in your lecture notes, but you have to check it. I just remind you that you have to know these two. 3i, it's f of x equal to the ln of 1 minus x. We did this one before and you have it. You know that you have to differentiate it, that you 1 over 1 minus x first, and then you integrate it to come back. So make sure you know it. It's a very important question. And you have it here. Okay, the tangent. You may have to work, get this one on the or one of the problems. You have one problem on that review that I gave you. So we differentiate first, and then from 1 over 1 plus x, we replace the x by x squared and we integrate to get back. So study this one. This is one of them, and the other one is the one for the ln function. So that's for the ln function. The other one is part g, h of x equal to the tan inverse of x. Both of them are going to be used in on the test, on the one that I gave you, and you have the solution here. You see, that's for ln of 1 over x. You differentiate it first, and then you recover it. You go from 1 minus x and you integrate to get to the original one. Okay, to make sure you understand. I do one of them so that make sure you can understand what we are talking about. You see, for example, 3i. So you have to connect it with the formula that we talk about it. So if you differentiate it, that's going to be u prime u. U prime is a -1 and the u minus x. Okay, now we know it. 1 over 1 minus x is the one that we can manage to get from that power series that we have. So the situation is going to be, we just note that from the power series, we have 1 minus x. You know that this is sigma of what? Sigma of x to the n, and n from 0 to infinity. Okay, so your function is, so your f prime is going to be negative of the sigma of x to the n, of course, the condition. You see n from 0 to infinity. Now to get back to your function, you integrate it. If you integrate, f of x would be, it's a negative. You're just integrating the inside. Okay, it's going to be sigma of integral from 0 to x, x to the n, n from 0 to infinity. And the integral is sigma of integral of x to the n would be x to the n plus 1 over n plus 1, n from 0 to infinity, when the absolute value of x is less than 1. Okay, so something is like it's happened the same for the tangent inverse. So you differentiate it to get something nice. You differentiate it to get that power series representation. Now you integrate it to go back. So this is going to be the famous version for the ln of, you see, ln of 1 minus x. You got it. It's a sigma of x to the n plus 1 over n plus 1, n from 0 to infinity, with the condition that the absolute value of x is less than 1. So you may use it for the Maclaurin series. You have one question on that worksheet. So you have to find this one first. Then it may give you something like x squared times. So you write it down and then you multiply by x squared. You have a x squared tangent. I'm going to do it, we have it in number 4, explain it. Okay, so and make sure you know these two. So that would be number 3, power series representation of these famous functions. That's the first part. Okay, now we have another group. That group would be related to the sine, cosine. In that case, you can use the Maclaurin series of the sine and the cosine, and you have to know them. So for number 4, is going to be Maclaurin series. You know, the Maclaurin series is the Taylor series of the powers of X, Maclaurin series. For this problem, you have to know the following. Even you can bring it to the test, we don't mind, because we are not going to ask you to prove this. Okay, so these are going to be, it's going to be used. So we let you bring it if you like, or make it available to yourself, and you can use it, okay, anytime you like. So these are going to be the following. So note that you are going to get 2 questions on this. So make sure it's ready. The first one is the power series for e to the x. Okay, it's 1 plus x. You know that, plus x squared over 2 factorial up to the x to the n over n factorial, whatever. Or in short form, e to the x is the sigma of x to the n over n factorial, n from 0 to infinity. And this is true for all x. The radius of convergence is infinity. Okay, so the radius of convergence is infinity. So this is true for all x. So that's the first one. The second one is sine x. Okay, the sine x is going to be, this is going to be the first term is going to be x, odd power of the x3 over 3 factorial, x to the 5th over 5 factorial, and you continue. The general term is negative 1 to the n. You have it in the review, all of them. X to the 2n plus 1 over 2n plus 1 factorial. In the brief form or sigma form, sigma of negative 1 to the n x to the 2n plus 1 over 2n plus 1 all factorial, n from 0 to infinity. Again, the radius of convergence is infinity, so this is true for all x. So this means if you need sine of 2x, you replace the x by 2x. The other one is cosine x. Cosine x is going to be 1 minus x squared over 2 factorial. Make a note, bring them available for your test. So it's going to be the even power. The general term is negative 1 to the n, x to the 2n over 2n factorial. In sigma form is cosine x equal to, okay, equal to the sigma of negative 1 to the n over x to the 2n over 2n factorial, n from 0 to infinity, and this is true all the time for all x. Okay, so these 3 formulas. The tangent inverse, if you have it, you have to prove it. Okay, but this one, you can use it on the test anytime you like, without any proof. Okay, e to the x, sine x, cosine x. Make a note and just make it available for yourself, because you get 2 questions directly or maybe another one indirectly related to these 3 formulas. They are very, very famous. The calculus starts with this one. When Newton he discovered the sine x, and this is the way your calculator would give you. You see, if you want to find a sine of 45 degrees, the calculator would use this one. Of course, x is going to be radian. So the calculator is quick and approximate this series and give you the result. Sine, cosine, e to the x. Okay, everything is related to the power series. Okay, so we give you 1 question to write in the Maclaurin series of a combination of this, not directly this one. Okay, so we are going to see these problems like part 1 on the 4. So you've been asked to write a power series or Maclaurin series for this one. okay? So what you have to do is you write the exponential function for e. Don't go for the differentiation, okay? It's very difficult, sometimes impossible. So what we're going to use, we are going to make it step by step. You make e to the negative 3x first. So we say, oh, note that I have e to the x, sigma x to the n over n factorial, n from 0 to infinity. No restriction for all x. So since for all x, replace the x by negative 3x. Okay, so replace the x by negative 3x. So that gives e to the negative 3x, sigma of negative 3x to the n over n factorial, n from 0 to infinity, but you have to pull this out. This is not a power series. It's going to be sigma of negative 1 to the n, 3 to the n, x to the n, n factorial, n from 0 to infinity. No condition is needed. Okay, so that's a power series or the Maclaurin series because powers of x. So you need x squared times it by x squared. Okay, times it by x squared. So multiply. That's for your information. You use it right away by x squared because x squared is powers of x. So it's not going to change this one. So that gives you x squared e to the negative 3x. And that would be, you take the x squared inside, multiply it here. Sigma of negative 1 to the n, 3 to the n, x to the n, no x squared, divided by n factorial, n from 0 to infinity. Now you simplify x to the n and x squared would be x to the n plus 2. So x squared e to the negative 3x would be sigma of, okay, negative 1 to the n, 3 to the n, x to the n plus 2, divided by n factorial, n from 0 to infinity, and then you're done. So this is true for all x. So you don't need to worry about the radius of convergent. Okay, so the key is this one. So you must know this e to the x. Then you replace the x by negative 3x to create e to the negative 3x. Then you need it multiplied by x squared, multiply by x squared to get the result, okay? So that's a one for the e to the x. And you have similar one for the sine, cosine. For the tangent, you have to make the tangent first, okay? So I do the sine first and I come back to that one later, or you can check it yourself, okay? One with the sine is a 4c. Remind you how you do the sine. So the 4c, you want to write a Maclaurin series for this one, f of x equal to x squared. It's x squared sine of the 7x. You have one in that worksheet that I gave you. Again, you have to make the sine first. So it notes that I have the sine of x, sigma of negative 1 to the n, x to the 2n plus 1, 2n plus 1 factorial. And it's free. You don't need to have any radius of convergence. But you need 7. Okay, replace x by 7x. Since the radius of convergence is free, you see there is no restriction on x. So you can replace x by anything you like. Anything you like, I mean anything in terms of the x. So it's going to be limit sine of the 7x, sigma of negative 1 to the n, 7x to the 2n plus 1 over 2n plus 1 factorial, n from 0 to infinity, no restriction. But you have to take care of these, okay? So the sine of the 7x is limit of negative 1 to the n, So that gives 7 to the 2n plus 1, x to the 2n plus 1, and this is going to be 2n plus 1 factorial, n from 0 to infinity. Nice. This is the power series representation for sine of the 7x. But you needed x squared multiplied by x squared. So x squared sine of the 7x is equal to, you put the x squared here, limit of sigma of x. That gives us 7 to the 2n plus 1, x to the 2n plus 1, x squared over 2n plus 1 factorial. Take care of this. So x squared, the sine of 7x is equal to sigma of negative 1 to the n. It's going to be 7 to the 2n plus 1, x to the, you add these powers. 2n plus 1 plus 2 would be 2n plus 3. 2n plus 3 over 2n plus 1 factorial, n from 0 to infinity. Nice. You may wonder, so we know what's the application of this? Quite a lot in future. Quite a lot, because if you're going to be in physics or all the part of science, you are going to have anything we do in those disciplines, the result is a differential equation. It's an equation in terms of the y prime, y double prime, and you need to find the y. In order to find the function, sometimes it's difficult. We have a method, we call it solution by power series. And this is where you get this. There are many softwares that apply this power series and give you the answer to many, many difficult questions. Because when you're doing an application, you don't know what's going to be the result. You may get something that you don't expect. But the power series will take care of for you. It's such a strong tool. It's a classic calculus. Okay, the calculus was created here, not just by, they differentiate the sign. They have this sign, say this is the sign. If the other sign is cosine, because differentiate cosine, you get a power series again. So that's the way they did those differentiation. Okay, that's one problem for the sine. Okay, I give you one for the cosine. One with the cosine. This one is a combination. You have to be a little bit more careful for this one. Okay, you see, these are all in sigma form. But this next one, you have to do it in expanded form, call it f of x equal to 1 over cosine of x over x. When you see this type of combinations, you better list the terms. Okay, we start with the cosine. So we say that, or note that you have your cosine. We talk about it, you can bring it. You write expanded form. Expanded form with the cosine start with the 1 minus x squared over 2 factorial. Okay, just a couple of terms will be fine. X to the 4th over 4 factorial, x to the 6 over 6 factorial, etc. Then you have to make this. You see, you need a negative cosine multiplied by negative number, negative cosine would be negative 1 plus x squared over 2 factorial minus x to the 4th over 4 factorial and the plus. And then you continue, you need 1, add 1 minus cosine of x equal to, it's going to be 1 minus 1 x squared over 2 factorial minus x to the 4th over 4 factorial, x to the 6 over 6 factorial. This 1 and 1 would cancel out. So that gives you 1 minus cosine x. It's x squared over 2 factorial minus x to the 4th over 4 factorial, x to the 6 over 6 factorial. Now you divide by x. Divide by x, 1 minus cosine x, divide by x. You see, divide by x, x squared divided by x would be x. This would be x to the third, and that would be x to the fifth, etc. That give you a power series. That's it. You can write it down in sigma form if you like, but you don't have to. Okay, and this is true for all x. That would be useful. Sometimes we have sometimes you want to find the limit of 1 minus cosine x over x, that goes to 0. So you find the limit of this part, which is 0, right away. Okay, so that would be a question of the Maclaurin series. It would be, check that tangent inverse for yourself, okay? So check the part B for yourself, or B. Or B for yourself, f of x equal to, it's going to be, okay, x cubed tan inverse of 3x. Okay, so we give you one question on this one, a couple of these functions as you have it on your review. Okay, so that would take us question number 4. Then we get the applications. So I'm going to take a break from this one because the video would be too long. Okay, I'll just come back and give you, the second part. Okay, so I'm going to post it separately, but you can watch them. So that would be up to the question, the topic number 4. Okay, I do one from each for the second one. Okay, so take a break and then we come back and we continue.